Today is all about road widening techniques, and the basis of this webcast is going to be an existing project that has been provided by a customer, and we've actually done training with them on this particular project, and we felt that it would be a good basis for a webcast. So let's have a look at what this project is all about. And I'm just going to show you, this is basically an existing surface that you're looking at here, an existing road. You can probably make out the existing crown, edges of bitumen left and right. And the idea is that in this particular webcast, we're going to look at widening, okay? And the basic premise is this: we're going to widen the right-hand side, and this would be the right-hand side as we look at it, of this particular road to accommodate a 26-meter B-double. We need to maintain the existing crossfall and also add a table drain. Now, for many people, you probably think, oh, it's really, really simple. And in some cases, it could be. However, we're going to review some of the different ways in which we have to approach this, so that if you haven't been using the software for very long, this might be very new to you. And it's a good way to kind of take a step back and have a look at how we might begin to do the design. So we've got two options we're going to try and attack in this one session. So it's going to be fairly brisk. Option one is this: we have the existing crown or existing centre line, which we just saw on that image a second ago. And we're going to design to the right-hand side to widen the existing road. Based on this, we're going to have a centre line code positioned at the existing surface, a saw cut positioned at the existing surface, and then maintain that slope all the way through to generate our edge of bitumen, followed by a shoulder, followed by a table drain. And the table drain is quite unique because that requires the position of the invert of this drain to be sitting 400 mil below the REB. We have varying crossfalls. So how on earth do we always have that 400 mil below and maintain a 1 in 4 slope? So we're going to look at how you might approach that, because it's not quite as straightforward as maybe thinking, well, I might put a variation or something on that. So that's option one. Then option two is slightly different. So in this case, the point of control, or the start, or the center of our design is actually going to be along the edge of bitumen. And we'll talk about this in a second. But we're actually going to be designing along the edge of bitumen and then putting codes out to the left and then codes out to the right. So a different approach, and there could be good reason for this. For example, what we might do is just very quickly, actually, before I go on to that, just look at the sort of final part. So we're going to do option one, then option two, and then we're going to actually plot option two. And the idea is that we've got a few different criteria around what we're going to do with respect to plotting. We're going to omit this section of design. For those of you that have used the software for a while, that's actually going to be quite a straightforward process of deleting the code. We're going to be putting constraining the section, the right-hand side of the sections, to be 1 meter past the batter. We're going to be showing a proposed barrier and labeling the existing crown and the proposed saw cut. Depending on how we go for time, we may or may not put in the saw cut, but we'll see how we go. So let's have a look at the drawing. So I have got Civil 3D with Civil Site Design here. So there's been a bit of work. There's no point us starting the webcast and creating Civil 3D alignments and surfaces, etc. It would have been utter waste of time for most of this webcast. So a lot of the sort of base work has been done. I'll come back to model view in maybe just a second. So these alignments are actually drawn by the, as I said, this is a real world job. So this is drawn by the user. And we have the existing crown. We have, so these are Civil 3D alignments, I should have mentioned this. We have a saw cut, the existing edge of bitumen, then our proposed edge of bitumen. And just to help you out, I've put this little key up here, or legend, just so you get a little bit of context later on if you forget. We've got the shoulder and then a table drain. So we have a Civil 3D alignment for each one of those. And because those codes all vary in position or in offset within the actual plan, the idea is that we're going to just use alignments to get them set up. Now, I discussed very briefly earlier the approach, one of two approaches, option one and option two. So option one is saying, hey, look, I would like to have a cross-section design all the way from the crown and work my way out. The other one is, I would like to design the edge of bitumen here and actually have some control over its elevations. And from that, I'd then like to have these points here matched on. And I'd also like to have a little bit of control over the shoulder and the table drain. So two very different approaches. Another reason might be that you want to plot cross sections. When you plot cross sections, they're always down the center of the string. So if we plot cross sections of this at the moment, this particular our first option, we will have the crown, existing crown, at the center of our cross section plotting. Whereas if we wanted to have the center at the edge of bitumen, that would have to be the center point of our string, or the key, or the sort of the master string, as it were. Now, they're going to require fairly similar processes and plans of attack, but we are going to sort of look at option one, do most of the digging in that one, and then look at option two, and a lot of the kind of description and work will have already been done by that point. So we've got Civil 3D alignments in play here to help us depict all of these individual positions for the codes. What we've also done is created a template. So the idea is that, again, I'm not going to sit here creating a template. We'll unpack the template that we've already created and explore it a bit rather than actually going through the creation process. So this is the template that we're going to be applying for option one. And you'll notice, first of all, that all of these values at the top are completely generic. So 1 meter, 1 meter, half meter, half meter. I know for a fact that the center line to the saw cut is not going to be 1 meter. It is going to vary because it's going to follow an alignment. So just to put something in, rather than putting in tiny values, put in something which is fairly representative, but obviously is not going to be used. On the right-hand side of the design here, we've got a batter. So the batter is the only sort of little change. We've got a 1 in 1 for cut and 1 in 4 for fill. So as far as templates go, this is relatively straightforward. Okay, the only sort of key difference with this, and we did mention this, is that there's a little bit of what we call advanced subgrade. Between the saw cut and the REB, we have 3 layers of subgrade, but there's a bit of stepping going on. So if you've never seen this before, this is how we manage it. So if you want to look at editing or applying subgrade between 2 codes, which is known as a section, which is this here, you can use edit section. So we're going to click on edit section, click OK, and then click between the 2 codes. This is where we can apply different layers of subgrade for visual purposes, or say, for example, for volumes. And you can see there we've got the 3 layers. Now, normally what would happen is that those 3 layers would just be stacked on top of each other, aligned with the codes. But we have the option of assign layer controls, which is basically advanced subgrade. In here, we can begin to override what that layer of subgrade would normally do. So each one of these numbers here relates to the layer of subgrade on the original form. You can see here that layer 1 has no differing values, okay? And I'll explain a bit more about these in just 1 second. So layer 1, 50 mil of asphalt, yep, no difference. Layer 2, however, layer 2 has 150 mil of an outside top extension. So when you look at this form, look at the image. This is really helpful to understand what's going on. Bear in mind, my template and this image are reversed. Okay, when it says outside, it means the edge of the subgrade, or the extent of the subgrade furthest away from the center line, which in our case is this. So for layer 2, 150 mil has been projected out. However, layer 3 is 0. So the temptation here is to put in 150 mil. That is basically adding 150 to that you've already put in. So if I leave it at 0, the subgrade maintains its 150 mil extension. On the inside, so this is the part of the subgrade closest to the center line, we have stepped by putting a minus value. So minus 150, then another minus 150 to step in. Again, the temptation could be, well, I'm going to just put 0.3, but that will actually be 300 mil from the previous step. If you haven't seen this form before, it's extremely good because there's some really good stuff in here where you can actually match the layer of subgrade to a surface, maintaining a minimum thickness. So if you are doing reconstruction work, this can be a very valuable, very valuable tool. You can apply and exit that, and apply and exit that. So we have our template. Let's have a look at actually applying it. So the first thing we would probably now do is go, well, I've got my template, I've got my alignments, I now need to create a string. And some people maybe get caught out by this, not necessarily caught out in the sense that they do the wrong thing, but not necessarily knowing, well, what's the best solution. First of all, let's have a look at the ribbons. So we've got grading strings at the top. So grading strings are based on polylines. They're perfect for freeform shapes, car parks, basins, etc., lots. So yeah, they're out of the question. Network strings, well, they're related to road strings. They're out of the question. Obviously can't create with those. So we're left with road string or profile string. So a road string is an intelligent string which will allow the connection of other road strings to it, and also allow the inclusion of network strings, none of which are what we're going to be creating today, but it also creates its own surface. If you're creating a string that just goes from A to B, okay, such as what we're doing, pretty much just does that, a road string is perfectly fine, okay? We could, if we wanted to, use a profile string. Okay, we wouldn't have the automatic surface being created, but there'd be no harm in creating a profile string. In this instance, we'll be using a road string for the centerline to apply our template. Then we'll be using profile strings to control the positions in elevation and offset of codes on the template, because the profile string doesn't speak to any of the other string types in the project. So let's get this started off. Let's click on road string, click closely to the alignment, and we're going to apply our template. And we're going to be picking the sampled surface in the background. This is a Civil 3D surface, and the samples are going to be every 10 meters. Now, I know for a fact that when I plot these cross sections, when it comes to section widths, that the sections down at this area where the batters are not going to be quite wide enough. And this is telling the software to read a little bit more of that natural surface. So I'm actually going to be putting 17 meters in here. Now, if you weren't aware of that fact until you'd actually got to the cross-section plotting, you can always just use resample sections. Basically, that opens up, by and large, the same form, which will allow you to go in and vary this number. So software's gone ahead and applied that template onto, with that string, onto that particular alignment. And if we right-click, we can see we have got this fairly sort of arbitrary-looking cross-section, which we'll come to in 1 second. The first thing we want to do is to match the existing, match the vertical design onto the existing surface. And you've actually got two ways of doing this. The first approach, which is the approach I'm going to be using, is the grid editor. If you haven't used the grid editor before, this does allow you to add IPs onto your design based on locations within the drawing. Normally, you'd add an IP on the vertical design, but this allows you to add an IP and position it in the drawing. One button that we can use here is this button here. At every sample position, the software will place an IP onto the sampled surface. Now, if we click that and say yes, you can see here the software has just gone ahead and done that for us in the background. I'm not likely to want to ever move the vertical design here again. So this one-stop approach of, yep, go ahead, match onto the existing surface is perfectly fine. There's no point me sort of looking at this in probably any more depth. You'll notice that there are some extra IPs being added in through the, and you'll probably actually see they relate to the curves. There's curves going on here. So for a Civil 3D alignment, we are doing some extra interpolation. Many of you that have used the software for a while would probably be familiar with using reference surface. And this says, hey, between a chainage to another chainage, match onto a surface, maybe use fitting, maybe adjust the chainage range. Don't need to do that with this string. It's match onto the surface and move on. So now the vertical design is done. I say done, obviously it's just matching onto the surface, so it's ready to go. We can then start to look at how the cross-section looks. Now, this cross-section window has already had some work done in it, which is why you're seeing blue lines. So if you're not sure what these blue lines are about, I'm going to explain. The blue lines you're seeing are the position of the alignments. Now, if I just pop back to model viewer here, which is what I failed to do earlier, those alignments I've actually placed into model viewer here as line marking. So it's just purely just a visual thing. Okay, I'm not planning on doing anything with the line marking, but this is a visual thing so you can get to see what's going on here. Each one of these alignments, okay, is part of the design, or basically constraining the design in some way. We can have those visually shown in the cross-section window, and it's an extremely good discipline to get into because it helps you see and contextualize your whole design. So I know that the saw cut has to match onto this alignment, the EB, the shoulder, and the table drain have to marry up to those particular alignments. To do this, you go to the display tab and you click on this button here. And again, we've already pre-populated it. Rather than me sitting here going through the pull downs and selecting content for 5 minutes, it's much quicker just to have it already ready. If you haven't used this before, always pick all in the first column. Don't bother with picking string names. You can then ask it to show a string level in elevation, which is something we'll do a bit later, an alignment, and another surface. So if you've got other surfaces in your project, you want to see maybe how they relate to the sampled surface, you can do that. I've then gone and chosen the alignments. These are Civil 3D alignments, and you can see there, I'm displaying all of them over a chainage range of 0 to 10,000. Now they're shown, that helps me validate the work that I'm just about to do. So the center line is in the right place. The saw cut now needs to be matched onto the existing surface, but at the position of the alignment. So we're going to use not only the right click method within this project, but we're also going to use the design data form. So I'm going to right click over the RSAW code, add variation, modify section. Real tendency with new users is go match code to alignment. Okay, and we are not matching to an alignment. We are matching to a surface first and foremost, but using the option of an alignment. Match to alignment is going to project that slope of 3% across until it strikes the alignment. Obviously, that's not what we want. Match code to surface. We have got the chainages already completed for us. Because I hovered over near the RSAW code, it knows that I need to use the RSAW code. The surface I want to match onto is the NS, and the alignment I already have created called road saw cut, and apply. Okay, so that's that first code sorted out. The REB, the REB and the RSH code need to be basically a projection of that slope. And as you can see, if I use my mouse here, and I'm just going to scroll my mouse wheel just on this ribbon up here, I can actually scroll through my cross sections. That slope varies. Okay. So I have no way of knowing what the slope will be for REB, but I know that it has to be a projection of that slope and be positioned on the alignment at the same time. To do that, we have to use a variation through the design data form. The reason for this is because the right-click solution has a sort of bank of key or core variations, but just for ease, we haven't stuffed it full of them. Okay, so we have a variation. And I'm going to access the design data form nice and quickly here for this string by going to this button, which will allow us to do what we're after. So I'm going to go add variation, and we're going to use match section slope to codes. So match this section slope, which is 8.41%, to that REB code. We're going to click OK. And we're going to just run this all the way through. So 0 to 1,000, apply this to the REB, and take the slope from the center line to the RSAW code. Caveat with this particular tool, if you are trying to use this based on a slope of codes on the other side of the center line, this will not work. Okay, so if you had an LSAW code to the center line and you wanted to project that to a right-sided code, this does not allow that to happen. Okay, so you can only use this with codes that are on the same side of the template. And we'll discuss how you can overcome that a little bit later with one of the tools. The optional alignment here is going to be the EOB. And you can see there we've got that slope being projected through. So at the moment, this is all fairly straightforward stuff, beginning to put this together quite nicely. One thing we now need to do is also do the same with the shoulder code. So the shoulder code is a projection of that same slope. So again, I'm just going to use the same tool. I'm going to copy the variation. There's no point me just recreating that whole thing from scratch, because really I'm only changing two things. One, the code, shoulder. Second, the alignment, shoulder. Add update. So very, very quickly, using some very straightforward design variations, we're able to take that template and completely manipulate it to position onto the alignments and respect existing crossfalls and existing surface elevations. The tricky bit is this, though. We're now going to look at the table drain. And the table drain has sort of three different bits or three different constraints going towards it. One is the fact that it has to be 400 mil below the REB. Now here we have varying crossfalls. So at the moment, there's no way I could ever know whether or not that code is 400 mil below the REB. The second one is that we have to maintain a slope of 1 in 4. and we have to try and, as best we can, use this alignment. So with those three things in mind, that code is going to be in a varying position horizontally all the way through the design, obviously, and vertically. So how do we do this? Well, the only way we can do this is to create a profile string along our table drain alignment and have the table drain string inherit the elevations that we need and then place the table drain code onto that string. So let's see how this is done. The first thing we need to do is to actually go ahead and create the string for the table drain. So I'm going to go ahead and close the design data form. I'm going to leave the vertical design open, and we're just going to go up and create a profile string. So a profile string does not interact with any other string in the project. It won't create a surface unless we tell it to. So it's perfect, and it's perfect for controlling the elevations of codes. So I have here my green polyline. There's an alignment underneath. That is the table drain. The other thing is, if you try and use a road string for this, there's no option which says none. Okay, so it kind of more or less ticks its own box. So no template, sampled surface is NS. What I am going to do, however, is use the sample positions of the main master string here. Okay, so I'm going to click on from other strings, and again, due to the fact that this has been created in the past as part of the process of this particular project, I'm going to just go and repick road master and use these changes only. And I'll show you this. I'll show in a second why you would do this. Section width's not really relevant. I'm going to click OK. So we've got a completely randomly generated, well, not randomly generated, but we have our vertical profile here. Let's just quickly turn on the sample lines for the road string. So there are the road string sample lines being positioned. These are where the cross sections are being drawn. Now have a look very closely at what happens when I turn on the profile for the table drain, the sample lines of the table drain. They're in exactly the same spot. Now, when you do run a constraint, constraints or design constraints, sorry, are projected along sample lines. So I know that a sample line position here and here is going to match, which means that it's perfectly well set up now for when we actually come to apply the constraints, because they're marrying up. Not 100% sure that you have to do that. Don't feel that you have to have them marrying up, but it's an extra sort of thing that might be of benefit later on. Now, the vertical design. For those of you that have been using the new version of the software, and I say new, 19.2, so nearly 2 years now, we employed the option of design constraints within the vertical design, vertical grading editor. And what I'm going to do is, first of all, just delete all the IPs, so wipe the design out. Then we are going to ask the software to show us where 400 mil below the EB would actually be. And we can do that by going up to design constraints. And we're going to go up here and pick project design code. Now, this design constraint does a multitude of different things. This is why I'm choosing it. I'm going to click on add, and we're going to type in 400 mil below REB. So the software automatically pre-populates all these cells at the top, so we can more or less ignore what it's done, but don't have to really change a lot. What I want to do is see on the string road master the EB code, REB. So let's just do that first of all. Click apply. That is currently where the edge of bitumen is. I need to be 400 mil below it. So I can come in here and type in a level adjustment of -0.4 and click on apply. Now, that is where I need my profile string elevation to be consistently. So there's a couple of ways we can now actually attack this, and it's done if I go back to the Home tab through Auto Profile. So Auto Profile, the plan was to try and attack as much of what's in here as possible, and really we're going to be focusing on two key tools. One is reference constraint, one is reference point. If you haven't seen reference constraint will allow us to go in and apply our vertical design or IPs along the position of a constraint, which is basically what we're after. So what I'm going to do, first of all, is not tell it to include the first IP and the last IP, because I need those to stay where they are. When you run delete all IPs will basically reset the whole design, but match the first IP and the last IP to your sampled surface. I just want those to stay there. So I'm going to say between them. So I'm going to go 1 meter ahead, and down here you can actually see the last chainage. So up to 209, match onto Now, it looks like there's two constraints going on. That's the same constraint, but there is a lower and an upper. They're both the same, so I can pick either, click OK, and apply and exit. So that first point has stayed where it is, last point has stayed where it is. So that string is now elevated to the right point, 400 mil below. What I wanted to show you was one other tool, because we're going to be using this in the next option, and that is using in auto profile reference point. So I'm going to go delete all IPs. So I don't know and haven't had a huge amount of feedback where folks have actually been using auto profile reference point, but I'm going to show you how it works. I'm going to unpack it a little bit more, certainly so in the second option. What reference point will allow you to do or assist you with is calculate elevations for your string based on slopes or no slopes whatsoever from other codes and other strings in your project. So if I had a string that was on the other side of the road and I had to be 400 mil below a code on that string, this is the tool I could use. So let's see how this works. We'll look at sampled surface when we look at option 2, but from design string says, from road master, from the, and I've just got to get my bearings here, what is it that I'm doing? REB. I'd like to, and this gives you the option to project at a slope. So if you wanted to be minus 3% from the REB, you can actually use this tool to do that. Now, I don't want to have minus 3%. I want to be 400 mil below. So I'm going to leave that at 0. Important we leave that at 0. And I'm going to put a height adjustment. So if I wanted it just simply to match the REB elevation, I could just leave this as it is, quite frankly, and that would work. What I'm going to do is say minus 0.4. The reason why I've wiped the design out is because this will help us confirm that it's happening as it should. Just before we do that, I'm actually going to just tweak that chainage range 1 to 209 so I don't get the whole thing being sucked through, and apply and exit. So you can see it actually achieves the same. Now, there is a slight difference for those of you that are well versed in the software. There is a slight difference in how this calculation occurs. The constraint is projected along the sample line. Reference point is calculated perpendicular to the origin. So these will have been calculated perpendicular from the REB code. So you can see there that's going to be pretty marginal. What we've ended up here is actually not using matched constraint, but using the constraint as validation for our design, which is what I've done here. So it's kind of handy that we can actually see what's going on. Now, what might be useful is having that same constraint projected onto our master string. So I can see the dot there, that's where it's meant to be, but it'd be nice just to confirm that that dot is actually 400 mil below the REB. So I'm actually going to add the same constraint here to the master string. So I'm going to go design constraints and just do exactly the same thing and call it 400 mil below right EOB. Okay. And I'm just going to, and if, by the way, if you're ever wondering why you can't see these cells, it's just because certain monitor widths have different allowances for width. So we just allow you to move that out. So let's go and pick REB from the string that we're currently on, minus 0.4. And just very quickly, just watch what happens with this constraint in the window here. So the constraint goes in here. We don't really care about the vertical design as such. The cross-section window, however, does have this constraint being shown from the REB all the way back to the center line. Doesn't really cover the point that I'm after. So just where it says offset, I'm just going to put in 5. Okay, so I'm actually going to say, well, look, if I was 5 meters away from the REB down 0.4, where would I be? Click apply. Great. So again, it's just validation. We don't have to do it, but it's helpful to see that it's happened. Now what we're going to do is just close that down. We're going to position the RTT code onto this particular point here, onto this string. So just very quickly, we did the string already in here by picking all string level table drain. Okay, and there's an alignment there as well. So I'm going to take the table drain code by right clicking, add variation, modify set, typically that's gone onto the other screen. Let's just try that again. RTD, add variation, modify section, match code to string. Now, the process of this is, yep, I want these codes to, this code to be matching onto the string all the way through. The code is already selected for me. Change offset and level. Might not be the right one, but let's have a look. table drain. So I'm deliberately not unpacking this because I want you to see what happens. So we have to be 1 in 4, but at that elevation. So that 1 in 4 in theory is going to be somewhere here, which is what we want to happen. Let's see what happens with this first method. Okay, so change offset and level says, hey, take that code and position it onto the elevation of the string and at the same time move its offset. So yep, no, that doesn't work at all. Okay, so I need to go and change the design variation. What do? I can right click, open section design data. Takes me straight back to any variations that are being applied at Cheney JC. So don't open the section data form up and think that you're going to see all of your variations on your string. You're only seeing variations and changes that are occurring at this chainage here. But that's perfect because we've got what we want. Let's go in and have a look. So hold offset and level, well, that's just going to leave it where it was, -4 down at its original elevation. Hold level and change offset. So that basically takes the original elevation and moves it across as if it was being moved onto an alignment, followed by, I'm going to skip the one that we want, hold offset and change level. So basically that's putting it down to the elevation we want, but it's obviously screwing up the slope. However, hold slope, change offset. Maintains the 1 in 4, jumps down to 400 mil below the EB. Okay, so it's exactly where we want it to be. And obviously, because of that criteria, that alignment is sort of being used, but at the same time, not all the way through. And in actual fact, if we just if we just move this over, close this down, you can actually see the table drain code is actually completely away from that alignment. But with the alignment was sort of there to give us that little that sort of start, as it were. So we've met the criteria that we want. The only thing is with that table drain, what if we go and change the REB? Okay, what if we do something with the centerline elevation, which impacts and knocks all the way back down, which could in theory change the position of this string? Well, we would have to go back in to the auto profile entry that we've created. I'm just going to close this down and reapply it. However, if you haven't used threads before, I'm just going to quickly come up here and go thread editor. This is a way of, and I'm not going to spend much time in here, but this is a way of having the software automate certain processes by running a string of actions. And the one action that I want the software to do without me having to keep opening up the VG all the time is to basically go and run the auto profile entry for the table drain. And so it basically rematches again. So the first thing you do is come up to the add button, and we're going to call this table drain update. Nice and simple. Click OK. Then you've got a list of actions. A lot of actions you can do. You could say, well, do A, do B, then do C, and then I want you to plot. Now, all we want to do is run this one at the top, and it tells you down here, run the auto profile entry. So I'm going to click on add action, click on table drain, click on add action. Now I can run compute thread. Nothing's going to happen because everything's in the right place. But what will happen is if I wanted to run that thread later on, just make sure everything's matching as it should be, I can come up to the thread editor, click on run threads, and there's my table drain update. Okay, so if the REB happens to move in any way, I can come in and have that updated again. So just before I run option 2, Andrew, have we had any questions? Just while we open up option 2, have we had any questions come through?
No, not at this stage. I think it's because you've been very thorough.
Excellent. That's good to hear. Well, we've got a lot to get through, so I'm going to jump onto option 2. By the way, you'll notice that part 2 here doesn't have a data folder. Yet when I open it up, you'll see in a second, there is civil site design content. For those of you that haven't seen pack mode will take a copy of my data folder and pack it into the drawing. Whilst I'm working, or when I start to open the drawing, a copy is unpacked, put next to the drawing. I operate as I do normally, but this is a great way of working with your projects. And in actual fact, in this webcast, I was actually going to just do a save as on that last job, remove what I didn't want, and continue working. So if you haven't seen pack mode, have a look at the webcast playlist for civil site design. There's a really good webcast where we unpack how to do pack mode, no pun intended. Right. Just because I've got total model kicking around, we're going to remove that. We're now going to look at the option which basically has the template positioned, or the centerline, along the edge of bitumen, and then we'll work to the left and to the right. To do this, I've already got a template created, and that is called left saw cut, right drain. So in this particular instance, we've got the saw cut over here and a match code, which is going to be matching onto our crown or existing center line, and a shoulder code and the table drain. So the table drain is still going to be using the same criteria, but it's actually going to be needing to be designed off the center line code, not the EB code. But this is the template we're going to be using. So we're going to take the same approach. Road string, we're going to be clicking on our EB or EOB alignment. And pretty much everything's going to be the same as what we did previously. Going to go OK. Now, I'm going to right click to open up a cross section window. The major change with this one is that I'm obviously not matching onto the existing surface. This elevation needs to be designed in the vertical grading editor based on the slope from the existing crown to the proposed saw cut. So I can't use a design variation because the design variation only works on codes other than the batters and the center lines. So we're going to have to take a different approach. What we'll do first of all, though, is get these codes in the right position so I can at least begin to look at how I would design the center line. So we're going to just use similar tools to what we used earlier. So I'm going to hover over L match, add variation, modify, match the surface. And we're going to just do the same thing we did earlier and pick the alignment. And then we're going to take the same thing and do the same with the saw cut. So right click, add variation. By the way, I've seen many people do this. A lot of people create profile strings and basically do the match the IPs onto the sampled surface to do exactly what this variation is doing. So if you find yourself creating a profile string and matching a code onto it, and that profile string is just matching to an existing surface, you can just simply use this design variation. You don't have to go through that process of creating profile strings matching onto surfaces. It's just a sort of little extra there. Let's get that onto road saw cut. Okay, so we now have the code positioned, those two codes positioned where they should be. That center line now needs to be a projection of that slope. The only way that you can do this, and this is why I'm actually running this solution. I'm not necessarily saying that the center line has to be along the EB here, but if you are in this position, how do you actually calculate the elevations? Well, it's done through auto profile again. So I'm going to delete all IPs. First of all, just wipe this out. Okay, it looks horrendous, but that's not our concern at the moment. We're going to go auto profile, and then we are going to be taking a reference point. So we can actually approach this in two ways. First of all, the way that we're going to approach it is actually the design string, and then I'll mention the sampled surface at the end. What I'd like to do is to take the slope from L match and L saw and have that projected onto my center line. So I'm going to take the string that we're working on, which is road right EOB. I want to work from the center line, sorry, L match. I could say I want to have a constant code from the constant slope from the L match code. In this case, I'm actually going to be using 2 points. And what 2 points will allow me to do is to say, look, between a code, which in this case will be L match, to another code, which will be L saw, take the slope between those two codes and project it to give me my elevation. Now let's just see what happens when we do this. It's going to be interesting. Okay, obviously doesn't work. Okay, well, what have we done wrong? Well, not necessarily anything we've done wrong. It's more to do with how the software calculates. And depending on what side of the template we're on, it can be a simple case that we've got the codes either the wrong way around or the way in which the calculation is occurring. Might not be quite how we want. So to resolve this, we just got this reverse slope button here. So if you do find yourself with the slopes being opposite to what they should be, check reverse slope, click OK, and apply and exit. So I've now got that elevation set up based on the slope from these two codes. And we could go through, create a thread, which says, hey, go and update this. If the L match or the L saw happen to change, I might want to have a little bit of tweaking in here. This is the great thing about the center line being on the EOB, is that, you know, auto profile has done a lot of the hard work, but I could now start to go through and manipulate this design. I could apply some design constraints if I wanted to say, look, can't be above a certain slope or below a certain slope value. In this instance, though, what we're now going to do is just to have a quick look at RSH. Sorry, the RSH, the right shoulder code. I can't use match section slope to codes because the codes are on the other side of the template. So I can't say, hey, take LSAW to centerline and push that code through. Just doesn't, it won't allow it. So I actually have to use the same process. And to save time, I have already created a profile string for the RSH code. So I'm just going to go up to the vertical grading editor for the shoulder, keep calling it RSH. So just a completely random vertical design for the profile string. This needs to inherit the same properties that the centerline inherited to get it into the right place. So I'm going to delete all the IPs. You don't have to do this, but it just helps clarify that, you know, what we're going to be doing, it has worked. I'm going to go auto profile, and in here, reference point. One thing I'm going to mention, and I meant to do this before without moving the cross section, is that we could actually use sampled surface. Sampled surface will allow us to read the surface between two alignments. Now we have an alignment at the centerline, we have an alignment at the saw cut. If I use sampled surface, the software will just read the elevations at those 2 points and do exactly what it did with the centerline, okay, which is why we've got this option down here. In fact, we might just do that. We'll go and pick the reference string. For some reason, we still have to go and pick this, but that's okay. Roadmaster. I'd like to use 2 points, and I'd like to use Roadmaster to road saw cut. And let's click OK and apply and exit. It may, and by the way, if you do get this message, this is just saying that in some instances, at the start and at the end of this particular design, it hasn't been able to calculate because those codes or the alignment doesn't necessarily occur on the same sample line, okay? Hence why we've got this nasty little glitch going on. Okay, so at the moment, we can delete that IP. At the moment, we don't really know if this is positioned in the correct place. So we're going to take the RSH code and move it onto that string. So I'm going to go RSH, add variation, match code to string. And in this case, yes, I want to change the offset and the level and use the shoulder alignment and the string. And as you can see there, that's gone completely belly up, which is fine. So we're going to go back to auto profile, edit the entry, and just going to double check here that we've got everything that we should, which I think we have. I'm just going to go reverse slope. If it fails, which it might do. No, there we go. So reverse slope is normally the reason for you not getting the slope that you're after. Look, and if I had more time, I would have gone and refined that entry and said, hey, after a meter and before the end, apply this. So I don't actually get the software trying to calculate in an area where it's unable to calculate. Really, the only thing that's left here to do is just to put the table drain in the right place. Okay, so the table drain is already sort of set up because this is a save as of the original project. However, the code that's being referenced in the auto profile is no longer EB. So let's just quickly finish that off and then we'll look at how we can do some plotting. So I appreciate we're going through a whole heap of stuff in this session. Auto profile, edit the entry, and we'll just in fact, what we might do is just delete this entry and just recreate it. So from design string, REOB, from the center line, be a constant 0. Just going to check this box, constant 0, height adjustment, minus 0.4. Click OK and apply and exit. And if we now open up, have a look at the cross section, we're going to take the RTD code, add variation, and match code to string. Hold the slope as we did earlier, match onto the table drain. So I've gone through that pretty quickly, but it's the same principles we looked at earlier. So 2 different approaches, but we're achieving the same goal with matching onto the slopes. So the key to that, those 2 options, whilst yes, there's a potentially a whole heap more we could look at and design, but we certainly don't have time to do in the webcast. The tools such as reference point, if you haven't seen it before, if you haven't seen constraints before, very, very useful tools that will help you and assist you with the design. Okay, because sometimes the variation won't give you exactly what you're after, but reference point is an excellent tool. Now we're going to have a quick look at plotting and getting these labeled up, depending on how we're going for time. So we've got about 10 minutes. So to save time, we have already created, or I've already created a style, which we're going to use to plot the cross sections of the right EOB. as is always typical, my AutoCAD is being told to draw a viewport, so we'll remove that. And let's go and have a look up here. So the first thing I'm going to do is actually load in a style that we've already got created, and then basically unpack the style to show you some of the content that's gone on there, because we simply wouldn't have the time to go through and create it all from scratch. So in my common folder, I've got one called Webcast. And this will now give us our updated sections. So the first thing we're going to do is, you'll notice here we've got this section going on between the existing centerline and the saw cut. And as far as my design goes, I actually don't want that to be drawn. The only way that we can manage that is to actually delete that match code from the template at present. Okay, now that match code was there to help fix everything else. So if I did want to put it back in again, I can do that. But for the purposes of what we're doing here, lmatch is going to be deleted. If you think that saying no here will not plot it, you're not right. Unfortunately, what no means is that it won't show an offset. It will still display the section line. So it's not quite doing what we want. Let's go yes and click OK. And then I'm going to just go update display here. Update display immediately. So look, that's a bit more along the lines of, and certainly from the customer's perspective, that was along the lines of what they're after. Now, we've got a few extra things going on here. First of all, we've got the height difference band. That height difference band has been added using height difference. So very, very straightforward, just with the cut and fill. That's been added up into this particular section. The key thing is sort of the key areas of this. First of all, the design is being told to be constrained 1 meter past the batter. So typically when you create cross sections, you go up to the basic settings, widths and text, and you would probably tick this box. Okay, 15 meters left and right of the center. You can override this by going to extra settings, section widths, double clicking on that entry. So everything on the left hand side is as per the basic settings, 15 meters. However, on the right hand side, for both the text element and the line work, so you can actually separate this. So you could say, look, the text stops, but the line work continues. We're going a meter past the batter. The main additions visually within here are the addition of these things here. So we've got a guardrail being added in. We've got a note here to say this is the existing centerline, and we've also got a little note here to say that this is the proposed saw cut. Okay, so let's have a look at how these have been done, because each of them has been done slightly differently, and they've all been done. Well, the first two have been done using layers and tagged objects. So let's just quickly have a look at how the guardrail has been added in. Before we go to plotting, under the cross sections pull down, there is a tag objects option. And this will allow you to tag CAD objects. Inevitably, in this project, they're going to just be polylines, and tell the software that you want them to be picked up on your cross section plotting. So you click on tag object, and then you select the object. And in this case, I've already given it a name. If you want to untag something, you just wipe that out. I've called this guardrail 2, and I've also done the same for another one down here, which is called guardrail 1 or guardrail. Very, very simple process. I can highlight them. Don't really show up that well when you highlight a polyline with width in that color, and display tag names. So there's the tag name going on there, and I'm going to remove the highlight and the tag name. So these objects can be picked up by the cross-section plotting. Let's have a quick look. So if I go update display, this just sends me back. When we pick layers and tagged objects, you'll create this entry here. So the first thing is we could say, well, do I want to draw a band, an entire band for our cross section? No. Do I want to draw a section line, which is the surface line? No, this is not a surface. Do I want section labels? Yes, I do. So I've ticked that. We'll come to that in a second. Configure source. So this is the first thing you do. What you've got the option of doing is picking, as you'll see in a second, layers and also tagged objects. So you could say, look, if you really want to filter things out, you could say, well, pick up tagged objects on a certain layer. Okay. And you could go and check that. Now I've just got 2 tagged objects. I want them to be picked up. So I'm not adding any layers. Underneath, you'll see that we can search left and right of the center line. So if I had tagged objects on the right side, which I was like, well, I don't want those being picked up, I can just put a 0. Or if I was going to the right, I could put a positive value in there. This is why we've written the word signed. However, in this case, I'm saying, look, search for these tagged objects 15 meters left of the center line. Then, if that object is completely 2D, which those polylines are, you can say assign the levels from a surface. So you could have two surfaces. So look, use the design first. And if you lose the design at any point, I'd like you to then resort to using the existing, or the NS, the sampled surfaces existing. If you have 3D objects, you can use those, use the elevations from those 3D objects if you want. So this is basically how we've set it up. Band offset or band controls are irrelevant. There is no band. Offset controls are not related. This is to do with filtering the offsets on your cross sections, which we don't need to be doing here. Section labels. So this is where you have to specify a label. If you've checked section labels there, you have to go in and specify. Out of the box, we give you quite a few of the ones that you've got in here. Block fence is one that we've actually got. So if I just click on apply, that's changed. Okay, so let me just show you. If you did want an alternative block here, okay, that was your own design, then you could use that instead. And I'll just show you what we've done for the guardrail. So I'm going to click on the edit icon. Word of caution here, don't go in and start working on the original. Always, even if it's going to be the same and you want to tweak it, just copy it first. So copy, then work on a copy of it. Don't start, because if you lose the original, you've lost it. Okay, so if you do make a mistake. So I've copied, called it guardrail, and simply changed the block that's being used. So this entry is already here. If I double click, the other good reason is because if you copy something, it saves you having to recreate it from scratch. Okay, so I'd rather not go through the process of creating this entire thing from scratch. Take something that's pretty much what we want and work with that. This list of symbols is all of the DWGs that are found in your common folder. So if you've been using the software a while, you'll be aware things like your title block, etc. They're all in here. So I've got that block, I've created it, I've made sure the insertion point is somewhere down the middle. Okay, just so happens that I need to scale it by 10 for it to be inserted. Click OK. So that's all I've done. Taken something that's already there, replace the block with one that I want, and we click OK and change it to guardrail. Let's have a quick look. I love the plug and play sort of option here where we can just sort of see how it looks, and there it goes. Now, we've taken a similar approach for the existing centerline here. So this is also using layers and tagged objects. As you can see down here, layers and tagged objects. If I double click on that entry, we have, again, same setup, section labels. The configure source, however, is different. Where the existing crown exists, underneath the alignment, I actually have a polyline called a line master. So I've said layers only and go and pick that again. I've then said, hey, just search left and right of this, only search to the left of the center line, 15 meters. If for whatever reason that layer occurred on the right side as well, I don't want the existing center line being drawn somewhere else, then use the elevations of the natural surface. Simple stuff. The only difference with this is the block. So again, I have to have a section label, and we've got one in there called existing crown. So I believe, if I can remember, I think we took the elevation of the vertical, elevation vertical, which I'll just show you what that looks like. Yes, we've basically done elevation vertical, and we've copied it and changed it to look like this. So I'll just very quickly show you how that happens. So again, elevation vertical, we didn't want a line. Okay, so there's a symbol, which is the little block at the bottom. Happy to keep that. We've got a line, which is basically a line being drawn up 20 units. Okay, so we didn't actually want that, so that got removed. Then we have text. Okay, so I'm actually going to show you our particular entry here, existing crown. So I took that, we copied it, we removed the line, and then simply went in and started to change the text. The text itself is set up at the top here, 2.5 mil, the style, the layer. Because this was all populated, I didn't have to go ahead and pick it. What we did do, however, is rotate it by 90 degrees and put the justification to the left middle, which is why the text is now moved across. And then put a prefix. So you could actually put existing centerline and then put tag name, alignment name, level. Okay, so this will look a bit odd. I'm just going to put an underscore here. Click OK, click on update. There we go. So centerline then it's got 62,624. If I'd have spent more time on that, I would have looked at the fact the decimal places are at 0, okay? And we could put an in. So I just wanted to show you how that's done, because it's a very simple, straightforward way of getting annotation and labels onto your cross section. And really the last one is the saw cut. And the saw cut has actually been done differently. I don't need to tag anything because the saw cut is part of our design. And under annotation, you can use something called symbols from codes. So it kind of does the same thing, but what it will do is it'll annotate a code on your template. So I can go to symbols, annotate symbols from codes. It creates this entry here. And I can say, put this symbol on a particular layer, chainage range all the way through, scale the object at 1:1. Don't think that you leave that at 0, and don't put in an X offset and Y offset unless you want that code or that position of that to be moved left and right or up and down. What code do I want to label? And then what label do I want to use? Now this label happens to be the same one as existing crown. I've copied it and replaced the word with saw cut, or saw in this case, instead of existing crown. So definitely a good example of how to work with content that's already there and start to copy. And then that simply goes in and labels that code. If I've repositioned it to, let's say, the shoulder, click OK, you can see that's now gone on, obviously in the wrong place, but you can see how quickly you can begin to change that. Really, that leaves, I think, everything that I wanted to show today. I appreciate it's a whistle-stop tour of the tools within civil site design, and certainly to sort of present 2 options and plot is quite a lot to pack in, but we do have the recording, and certainly what I'm hoping is that for many of you, you'll go away and be able to actually look at some of the tools that have been applied, and we should open up Model Viewer just while I'm whittling away here. Let's just pop that up. There we go. There is wonderful totem all. Look at the tools that we've been using today and see how you can take them and apply them to your projects. Every project is different at the end of the day. So there is no one case where we say, oh, well, you know, you need to design it that way. As we saw, we could have approached this in 2 different ways. In actual fact, there are multiple different ways we could have approached this design. We could have been working from the table drain back. But hopefully, as I said, with what you've taken on board today, you'll be able to go away and apply some of this knowledge on your projects. Which really leads me to hand over to Andrew if there's been any more questions.
Thanks, Jonathan. Look, just the one question, just related to batter labeling on the cross section. I imagine the question was related to if the batter was labeled using the same processes, and if that is the question, then that is the case. I mean, you could tag any position of the road and then label that up.
Yeah. Yeah. At the end of the day, if it's part of your template, then yeah, go and use the symbols option. If it's not part of your template and it's just a feature within your drawing somewhere, then go and tag it or use a layer. Okay. Unless there's anything else, Andrew, I might book in the session.
Okay, no worries at all.
So next Wednesday, not Thursday, we're having a change. Next Wednesday, we will be having the Civil 3D sections and section views webcast. So if you're interested in attending that, feel free. And really beyond that, we won't be looking at webcasts until well into next year, probably around either late January or early February.